Hello everyone, and welcome to today's presentation. My name is Scott Boutler. I'm the Academy instructor here at the Langley, BC office, and I'll be the voice behind the screen today for you. The topic today that we've selected is using coding address 38 as a diagnostic tool. This webinar, just like the other webinars that are part of the technical training series, has been created to complement the information that we have in our product documentation. So those manuals that come with all those boilers, this is just to add to the information that we provide with that documentation. We're also going to archive this presentation as well with the other presentations that are part of the technical training series, and that will be available on our YouTube channel as well as on our Viessmann Canada website for future use. So if you need it, it's going to be available for you there. Joining me today, and we are at a safe social distance today of about 4,500 kilometers, is our head Academy instructor out of our North American headquarters, Mr. Mark Norris. That's a pretty long handle there, Mark.
Yeah,
good morning.
If I can stand up to that head Academy instructor thing. Welcome everybody. Just a little housekeeping before we get going. Scott's carrying all the heavy weight here, so I'm just in the background answering questions. So if you have questions, there's a question box. You can fill out the question, and we will respond to those. I will probably type in the answer. If you want an answer just to you, then make sure you put in your question that you want to answer privately. Other than that, your questions are going to get answered to the group. If we have questions that I can't answer or we don't have time to before Scott's finished talking, we'll take a few minutes at the end to go over those questions as well. You can also send questions to us by email. Our email addresses are available very readily, so you can send us an email and ask us questions, and we'll get back to you at some point in the future. So those are the questions that you think about in an hour from now or tomorrow or the next day. And I'll be here in the background while Scott's, like I said, carrying all the heavy weight. So I'm just going to let him carry on. Thanks, Scott.
Yeah, thank you, Mark. So you got Mark and myself here at your disposal. So any of those questions, as Mark had mentioned, if you want to get those out, now is the time to do that. We are going to be about 45 minutes to 60 minutes here today in this particular presentation. I'll warn you ahead of time a little bit. We're going to be doing some wiring schematics in this particular presentation or webinar as well, moving through the controls and showing you where the power is kind of going when the boiler is in operation. So there'll be some of that interesting information if you're into wire schematics. If you're terrified like most people, don't worry, we've got it nice and color coded. It's going to be pretty straightforward, I'm thinking, and hopefully very helpful to you to understand what happens when you push that little start button on the face of the boiler. So now that we got everything kind of set aside as far as the introductions and the timing that we've got going on here for today's presentation, let's get the training started. So the first thing to kind of review here would be what boilers you have this address available on. So we've got a fairly vast product line, residential and commercial. This kind of splits in between that area. It's kind of not really a residential boiler. It's not really a commercial boiler. It kind of blends between that. And we also are heading through multiple generations of boilers here as well. So it goes back in time as well as into our current products. So the first one we'll look at, the middle boiler, is the B2TB. So some of you guys may be familiar with this particular boiler out there. It's a true residential boiler of the lot that we're going to be looking at here today. It's a standalone type of boiler, combi, built-in domestic hot water function. So when you purchase this boiler, the domestic hot water package is already installed, your sensors, your pumps, your tank, etc. So pretty much plug and play on the domestic hot water side. You'll see the inputs here for this particular boiler. B2TB, you'll notice it also says B2TA on the information here. So there was a previous generation of that B2T series, a change in the heat exchanger. If you went through some of our previous seminars and webinars and stuff, you'd understand between the difference between an A and a B style of heat exchanger in these boilers. If you don't, then we have information archived about that, and it'll probably come up in different presentations in the future. But there are two different generations. Currently, we're only selling the B2TB 125, so that B2B68 is not available currently, just the B2TB 125. However, everything in that B2T series would have that address 38 available on it as we move through. As well, the B2HA and B2HB series of boilers, you'll see the Viessmann 200. This is the boiler on the left-hand side on the screen here that you're looking at. I've outlined in shaded in red here the first generation, the B2HA 19 to 60. That has actually been replaced with a second generation, the B2HB. You'll see those guys in a minute. And of course, the B2HA 80 that you'll see at the end is still available as the first generation. Everything now that has a B here is a second generation of those boilers that we just saw that were shaded in red. So from the 19 up to the 199,000 BTU boiler, all will have the ability of looking at and finding this address 38 and using it as a diagnostic tool. And carrying on, so now we're in the top end of the B2HA boilers from the 311 up to the 530. So you get about 10 different boilers that we currently sell in that Viessmann 200 line, B2HA or B2HB. And then we're going back with the WB2B as well. So the guy on the right-hand side, that little picture is of the WB2B generation. That was previous Viessmann 200 to the current products that we're selling in the B2HA and B2HB. But not every particular value in coding address 38 is going to be applicable to the WB2B. I will detail which of these values are specific to different boilers as we move through here. You may not understand that now. You will have a very good understanding as we when we finish this little presentation up here. All right, so the first thing to know is how are we going to get into and find this address 38? Where is it? In the boiler. It's in every one of these units, and as I mentioned, regardless of if it's a standalone boiler that you're dealing with in a residential application, or you're in a commercial building with 8 Viessmann 200s all wired to a cascade, that address 38 will be available for you in those Viessmann 200 units. So the first thing to kind of get out of the way here is some confusion sometimes with coding levels. Coding level 1 and coding level 2. Coding level 1, anything you do to change a value in a coding level 1 area will make the same change in that address in coding level 2. It's just coding level 2 has more accessible addresses. Coding level 1 is a bit of a watered down, kind of a more of a startup type of coding to make any simple adjustments. Coding level 2 has all of the values specific to that particular boiler. But not every code has been assigned to the boiler, which means if you don't have domestic hot water as an application for that particular site or that job, there's no tank, you don't have the domestic sensor hooked up to the boiler, when you get into coding, you're not going to see any domestic hot water coding addresses because the control is smart enough to know if you don't have anything plugged in for domestic, you don't really need to make any changes to those particular values. So you're only going to see what you actually have as far as the level of heating equipment attached to that particular boiler. So kind of moving on from that, I'm just going to give you a little definition of what those coding levels are. How to get into them. We start off by pushing 2 buttons simultaneously, the OK and the very bottom button, the menu key. You hold those down for up to 4 seconds, and that's going to move you into the service level of your control. And in here, you've got all those different areas for troubleshooting, things like diagnosis, actuator test, there's fault history available in there, and some other areas to navigate through. But to get into coding level 2, we have to move our fingers now from the menu key to the back key. So we go from the very bottom of the control to the very top of the control for coding level 2, hold the OK and the back key down for 4 seconds, and that's going to put you into that level 2. You'll see that on the screen, and then you'll have all the different areas that'll show up, what groups that we're looking at. Now you can see that in a standalone application, you got a lot more different things that are going to show up on that menu in the boiler. the control you see on the screen here right now was part of a multiple boiler system, which means it was part of a cascade. It had another boiler attached to it. And you'll see that when that occurs, you only get really general and boiler information. Whereas if it's a standalone application, you would have things like domestic hot water, possibly solar, and the heating circuits available in coding level 2 as well. For address 38, we need to get into boiler. So we need to scroll down to boiler. That will be available to you regardless if it's a multiple boiler system or a standalone boiler system. And using the arrow keys, you're going to navigate to address 38 in coding level 2 in the boiler group of our coding. And important to the first off with address 38, it's going to be 0 if the boiler does not have a call for heat. So if it does not have a set point and is not trying to fire at that particular point in time, then that value will be 0. If the boiler has a call for heat and there's no issues, so the boiler is actually firing and it's doing its thing, you go to address 38, you'd also see 0 there. The only time that value is going to change from 0 to something else, you just see here on the right-hand side, just above the picture of the boiler screen, is when the boiler has that call for heat, it's not firing, and you're going to have a look to see if what that particular value is. Or if we've got a fault on the boiler, that address 38 will be a value other than 0. So let's have a peek at what I'm talking about here. So we've got your fault code. So this is a picture right out of the manual of our troubleshooting guide for the Bulletins 200. I think this is a B2HB 19 up to the 125. And if the boiler is in a fault, so now you actually have a fault and the fault light's illuminated, the first thing we do is push the OK button as it tells us on the screen here, and we're going to see that fault. So you see the fault code on display in the fault codes there to the right, and you'll see something like E4, E5, E7, EC. One of those faults in the manual will be displayed on the screen. The address 38 is going to pop up a corresponding detailed fault code. So if we had, for instance, a EB fault on the screen when we push the OK button, if you went to coding address 38, it would have 189 as the value instead of 0, for instance. So that's kind of how this works. Let me show you how to use this as far as a diagnostic tool when the control is actually flashing a red light at you there. So that red light is illuminating. We'll have a look at that here in a minute. But in order to kind of get those diagnostic fault codes, what the detail of those fault codes are, we need to access the technical service bulletin that's available for these particular boilers. To access that, you've got a couple of options. You can go to our website, and on our website here, Viessmann.ca, we have our Pro Toolbox area. In that Pro Toolbox area, if you click on it, you'll have the current product manuals, historical product manuals, fault code checker, and the technical service bulletin area available there. You can also sign up with the ViessmannOrange.com app, put that on your device there, your tablet or your phone or laptop, whatever you're using, and you would have access to these technical service bulletins at that particular point of time as well. So we do our best to get these this information into your hands and have it available for you. The technical service bulletins, if you click on that, basically right now there are about 12 different bulletins that are available on the website or on the Viessmann Orange app. And the technical service bulletin related to address 38 would be the TSB-009. So we're down here, default or detailed fault codes at coding address 38, and it details the Bulletins 200 and the 222 boilers as we've already reviewed. So now we've got the information, we click in there, and you can download either a PDF, so I think it's 3 pages or so of PDF files that you get with these detailed fault codes, or you can have an Excel spreadsheet, that's going to be available. You can load that into your computer as well. So there's a couple of ways that you can get access to this information. And this is how you would use it. So if you had a fault, for instance, that was actually causing a light, red light there, lamp on the boiler to light up, illuminate, you get into an example here where you hit the OK button on that boiler and it said a EC fault. And you notice the EC fault, it has a value of the detail fault code is either a 67 or a 195. So when it has an either or here, you look at the information, and if it was a 67, then the parameter fault during calibration, you would push the reset button. If you had the EC fault and you went to address 38 and it was 195, there would be an extra step. You'd have to replace the boiler coding card and then push the reset button. So there it basically defines a little bit more detail for you when you have that fault and what you're going to do as far as the troubleshooting, basically to trace that out, diagnose it, and then correct the fault. So that's how we would use that. Some of the faults, basically, most of them just have that one detail fault code. They'll have some information in there, but when it's the either or, it comes in handy because now you can see what other steps you may have to take based on that code that you see flashing on the face of the boiler. So there's that EC at 67 or 195. There are some of these detail codes that actually don't have a fault code. So you notice the ones highlighted in red here, if they don't have a fault code, the burner is in hold or await state. So it's not going to display a fault. So you're not going to have a red light flashing, but these particular values, if you go to address 38, indicate that the boiler is waiting for something to happen. So something external needs to occur, and then of course it's going to correct that issue and the burner would actually operate without a problem. So you're not going to see a red light indicating that you have a fault, but the impact if that address 38 is in any one of these values that you see here is that the burner is blocked and it's not going to fire until whatever is blocking it is corrected and the unit is allowed now to fire safely. So we've got these particular codes. We're going to go through in detail here these specific address or values of address 38 that do not display a fault on the boiler, and how to correct these, how to navigate them, so that you've got that information and you can use that and utilize it to basically get that boiler back up and running. So specifically, we're going to look at if we have address 38 as a 2, address 38 as a value of 3. Address 30 is a value of 29, and address 38 as a value of 33. So these are the ones that we will see flash up on that address 38, and I'll give you the information here to help you correct those. The manual now has that information as well, so you don't really have to go to the technical service bulletin to get this information. It's now part of the actual service manuals as well. So it And if you open up the troubleshooting portion of the service manuals, at the very end of the different faults, you'll have this list of these particular faults that don't actually cause the red light to illuminate on your burner control. So these are detailed in a couple of different areas. And the first one we'll start off with is if I go to address 38 as a service tech, boiler's not firing currently, but it does have a call for heat, so I've checked and there's a set point on the control, and it hasn't met that set point yet. Go to address 38 and I see that the value is 2. If I look at the information that I have in the manual, it tells me that that particular value 2 says that there's no gas supply, or we have low gas pressure detected in the boiler. So the unit is blocked because the control says there's insufficient gas pressure for that boiler to safely fire. And what we're looking at here is specific to a particular size boiler. So this would 38 as a value of 2 will only happen in a couple of boilers of all of the ones we talked about to this particular point in time. We see right here the wiring schematic for the Viessmann B2HA 112 150 or the 309 or 530, depending if you're talking kilowatts or BTUs. And the information that we need to look at on this wiring schematic, what is it indicating as far as where the issue is lying, that the value of 38 is at a 2, is that we have an issue with the low gas pressure switch that is connected to this particular series of boilers. So the two sizes 112 to 150. Specifically, address 38 at a value 2 will only impact this particular size of unit. They're the only two boilers that actually have a low gas pressure switch installed on the gas valve when you purchase it from the wholesaler. So this is a little breakaway view. There's the technical data manual regarding the particular boiler that we're dealing with here. A little cutaway of what you're looking at here. And you can see that gas valve sitting in the bottom just below the heat exchanger. And of course, a little exploded diagram of the gas valve to the right-hand side. We'll have a look at this gas valve a little more closely. So gas valve, we've got a connection here that I'm showing you. In order to test your gas pressure, so if address 38 is a value of 2, it's telling you there's low gas pressure there. There's the test port. You can put your pressure gauge on there and have check your pressure. The back side of the gas valve is where that pressure switch is actually sitting. So this is the GDW1 is the low gas pressure switch that basically blocks the burner from firing if we're down below the setting. And the setting of this is 4 inches. So if we don't have at least 4 inches on the gas valve, then that switch is going to stay in a closed position. So instead of closing with gas pressure, actually opens with gas pressure. And that's a pretty interesting thing to note in the fact that if you have a situation here, you can, in order to test that switch, you can also just unplug the switch, as you see right here. If the burner fires, we know at that point that it was the low gas pressure switch that actually caused that burner to be blocked. So one of two things would happen if you do that. The burner fires up and everything works great. You want to check your gas pressure there to make sure that that's not dropping down below 4 inches during operation. If it does drop below 4 inches, you're going to get cycling of the burner, most likely as it tries to ramp up, or you'll get a fault. If the burner goes to light and you end up with a fault on the control, as you see down below here, and you have an EE fault flash up on your control screen when you push the OK button, that's telling you that you didn't have enough gas pressure at the get-go here. So address 38 with a value of 2 is pointing you towards this little gas pressure switch on the back of the gas valve and this little connection that we have available there. So a quick test is just to remove if the burner fires, then we know that that's the issue and it's either going to fault out or continue to operate. If the gas switch is faulty, obviously you have to replace that. We can't leave that in an open condition as we see here. It's just a test, which means that it's a safety. And as far as CSD, we have to make sure that those safeties are kept intact. We can't walk away with those safeties left in an open or a jumped position. So that's just a quick test of that, but address 38 of 2, we know that burner's blocked because we're waiting for the gas pressure to get up above 4 inches. So we're in a wait state. Now, if we have a different value, so go to address 38 and we're dealing with 3, this is kind of the opposite. Address 38 at a value of 3, you're not going to see on a B2HA 399 or 530. You'll see the value 2, but you're not going to see the value of 3. And if we look down below here, the value of 3 indicates that there's no water circulation around the boiler. So check for boiler flow around that primary loop. So the unit is blocked because it has no flow. So no red light, but we got a value of 3 here. So in this particular area, again, there's going to be no B2HA 399 or 530, but you'll notice that on the wiring schematics here, there's the B2TB model, 1935. There's a highlighted in red here is the issue at hand, or the part that's basically blocking the burner from operation. There's the B2HB 57. On the other opposite side is the WB2B. So this is the WB2B boiler is included in the value of 3 in address 38. So this kind of deals with a couple of different generations. But there are no B2HA 399 or 530s. The reason being is that when you see 3 at address 38, it's indicating that the flow switch has not closed yet. And the B2HA 399 and 530s use a flow sensor, a couple of flow sensors. So instead of a mechanical switch that closes when there's appropriate flow, with the larger boilers in the B2HA 399 and 530, that sensor indicates and picks up a minimum flow rate and allows the burner to fire based on that particular flow rate. So these are basically, these boilers know one particular flow rate, and that's the one that closes the actual flow switch. So we see these numbers here. So the smaller boilers, you're just down below a gallon a minute of flow to make sure that switch closes. Some of the larger boilers, you'll notice up here in the middle area, as well as over on the far right, you'll notice that there's two flow switches instead of just one. Some of the boilers, the 285, 311, 352, and the B2HA, as well as the WB, 2B, 80, and 100, or 105, sorry, those particular units had two flow switches put in series. Just the way the heat exchanger was created, it needed two flow switches instead of one. So you'll be dealing with two flow switches on some of those boilers. You'll see that B2HA 285, 311, and 352. We have two flow switches at 2.65 gallons a minute, so we need at least 5.3 gallons or that boiler is not going to fire. It's blocked on the flow switch. So simple thing to do here, what we would typically do if you call tech support, a lot of times they like you to remove the 33 connection from the flow switch and put a jumper in that connection. When you put the jumper in with the boiler powered on, this is similar to unplugging the gas valve plug that we just looked at, the low gas pressure switch plug on the larger boilers. When you short across the 33 plug here down the control console, effectively you tell the control that there is sufficient flow. That's what the flow switch does. It just completes a circuit, allows the burner now to go to the next phase of its ignition, which would be the burner comes up, does a pre-purge, and then it goes to fire. So if you put the jumper in and the burner goes up and fires, usually one of two things are going to happen. Your unit's going to operate, modulate, do all the things that you expect it to do. You could, at that point, do a continuity test across the flow switch that's unplugged. And if that flow switch is still open, it gives you a pretty good indication that that flow switch needs to be replaced. So it's blocking the burner from operation. If, however, you end up with a fault showing up on the screen after a few moments, that would indicate that there was insufficient flow. Typically, you would have an F2 fault or fixed high limit fault that would be created when we trip without any flow through the boiler, but we jump the flow switch. It's actually a test of your fixed high limit in some jurisdictions. And the point that we'd have to address here at this now is we do not have flow through our boiler primary loop. So we would have do things like checking the amperage on the boiler primary pump. So this is the 20 pump output. You're going to see that 20 pump output here in a little bit when we look at the pump module. But I'm just checking the amp draw on this little pump to make sure that it's functioning correctly. You also may want to you might have air in your system, so you can use the #1 keychain in I think now #1 in the world, if I'm not mistaken, Mark, is the Viessmann keychain. I think it's pretty close. We have a number of them out there. Yeah. Or check your pressure. So basically, is the pressure down in your boiler? Get that pressure back up. If there's no pressure, the pump can't basically push that flow switch closed, and you're going to have some issues. So there's some problem with flow with a value of 2 at address 38. And if the flow switch is not the issue, then we're looking at some sort of problem with movement of that fluid through the boiler, whether it's a pump issue or air or pressure or some isolation valve closed or some combination of those particular problems. So again, there's no fault lamp that's lit up here, but you're going to be able to navigate through and troubleshoot this fairly easily with the information that we see here in front of us. If we move now to address 38 being a value of 29, so we looked at it being a value of 2, gas pressure specific to the 399 and 530s. We have a value of 3 at address 38, which is going to be the 200 boilers that have a flow switch in them instead of a flow sensor, dealing with blocking the burner from operation. And now we have a value of 29. And if you see 29 on the control screen, that burner won't be firing. you will see that it tells you that there's an open circuit between terminals 1 and L on the multi-terminal or plug down at the pump module. And the troubleshooting that it says is to check the connections between the 1 and L, and check around the power of the particular area to see where that power has been interrupted between the 1 and the L. So that is going to get us into a little bit of a looking at the wiring schematics of these particular boilers. So here are the schematics, and you'll see the top here is the control console on these schematics. Down at the bottom is the pump module and the little EA1 module that you see down the junction box that sits down below the boilers here. And we're going to have a look at how that power moves through these particular areas of the boiler. It's all the same how the power moves through these units, whether it's the smallest B2, TB, all the way up to the largest B2HA 399, 530. The power goes through the exact same way as we go through here. So we're going to have a quick look at this. In order for you guys to know how the power moves through here, we got to kind of lift the veil here a little bit. So we're going to remove the covers off of the controls here. So I pop the cover off the pump module. So that's kind of what you see inside of the pump module. Some relays in there we're going to talk about, some connections down at the bottom that we typically see in the field, and some of the different things in that printed circuit board we're going to review here in a minute. And then I flip the control cover down, control console down on the boiler, and took the little plastic cover that basically keeps the moisture out of the controls. So now you can see all that factory wiring inside of the control console as well. So where is the power going when we wire this boiler up? It's going to go through some of these little relays here. So when we took the cover off, you see a bunch of these little ice tube relays, and each relay has a number here. So I'm going to highlight those numbers a bit for you. They're in no particular order. You've got K1 through K6. Each one of these little ice cube relays closes for a very specific function. So if that relay stays open, then that function is not going to be completed. So very important that the sequence of operation is kind of followed as we move through here. In the wiring schematic, it details the relay coil as A. So you'll see in the schematic, you might see K6A or K1A, K2A. Those are the relay coils that when we apply 120 volts, so they're all 120 volt AC switching coils on these relays from K1 to 6. When I energize the coil, then switching contact B is going to close. So on the schematic, and you'll see it here in a second. So go back to the schematic here. When K1A, which is the coil, when I energize that with 120 volt, K1B down here is going to close and allow the power to move past that little gate and move to the next point where a relay would have to close that power to continue. K2A energizes, when you energize K2A, it closes the contact at K2B. And K3 closes K3B. K4, I think we're all getting the picture here of how this works, but they just separate in the document. This and this are one component. That's the relay. We're just separating the coil from the switching relay down here at the bottom. All right, so we move through that, open up, and I look at the control schematic. So now I've got the complete wiring diagram on the screen here. I've just split it in half. So there are my connection points. We count the connection points up here. So go down here, 1, 2, 3, 4, 5, 6, 7, 8 connection points. So same with this, we counted up here, those are 8 connection points on the pump module. And where is that connection point? It's going to be down here on the pump module. So we see that we got 9 terminals here on our pump module. These are the connection points between the pump module and the control console at the top of your boiler. There are only 8 connection points. Terminal 4, you'll notice here, is empty, so nothing goes to terminal 4, but we're populating the rest of these, and each one of these from 1 through 9 here will energize one of those coils we just looked at from K1 to K6. So back to the schematic here. Now that we know what we're looking at, When I wire a boiler, so I put that power down here just starting out, and it's polarity sensitive. Remember, we're doing a flame rectification. You want to watch our EB and EE fault video to kind of get an idea of how polarity will affect or impact your burner operation. But we're polarity sensitive, which means line should be 120 volt to ground here, and neutral should be 0 to ground potential. There's our 40 plug, so that's where the power comes in from the field. And then the line voltage, so the L here, we'll color that in red. It's going to come up to the pump module here, and it's going to split off, branch off here in a couple spots. So the first area it branches off to, we're going to color that in blue. It's going to hit the F1 fuse. So we have a 6.3 amp fuse here. That power branches off and moves through that F1 fuse. And then it sits and waits for this little relay to close. So now the power is sitting there waiting for this contact to basically be made so that power can move through the control further. The next area where the power branches off, it hits the F2 fuse just above, the same exact same fuse, 6.3 amp. Moves through there as long as that fuse is not popped, it's closed. And it sits again waiting for another relay, or basically a relay here to close to allow that power to go past that particular point. The neutral, so we'll kind of start off, that's kind of where the line voltage kind of sits on your pump module. The neutral, when we wire that, is going to branch off to all of your outputs on the pump module, as you can see in purple. So it just sits there waiting to complete the circuit, and also moves up to the top of the pump module to a 40A plug, a little blue plug that sits up at the top of the pump module. Now I'm going to do the neutral first, and then we'll move on to the line voltage. So carrying back with that neutral that's purple, the first thing that's going to hit when it comes up from the pump module is another 40 plug. So a green 40 plug that sits in your control console, and then it sits, once we plug that 40 plug in, it sits at S1. So S1 is your power switch. So if I get Mark, could you push the power switch there, get the power on for me, please? Thank you.
My fingers are long enough to do that.
So with Mark's assistance, the switch is on, and you see that neutral now ties off to all of the different components on the burner. So everything from your burner fan, your gas valve, some pump relay outputs, 21 and 20. And then it comes up to the 96 plug that sits just to the left of that 40 plug. You'll notice that if you're looking at that the power, that neutral splits off. So there's actually parallels off. We're just going to follow it back down the control console first. We'll come back to this little branch in a bit. So we're back down here at the control, from the control console back to the pump module, and that neutral sits at X1-7. So we're wiring right here to the X1-7, and that basically ties the neutrals on your relay coils. So all those coils, the neutrals are powered. As soon as we push the power button, the neutral is sitting right there ready for that contact to be completed. So that's just on the push of the button. That's what happens. The line voltage does the same thing. So it hits the 40 plug at the top of our control console, goes to the power switch. Now that the power's on, it moves past that to another fuse. So now this is the control console fuse that protects the control console. There's actually a spare fuse in the fuse holder at the top of the control. This particular fuse is the same as the ones we looked at down at the pump module. So the F1 and F2 fuse down at the bottom is this exact same 6.3 amp fuse you have here at the top of the control. So there is a spare fuse in there. So you have one more shot to pop a fuse before you have to go and buy some replacement fuses, but it sits in there. Once it goes past the fuse, again, it goes to the line voltage is sitting here now on all of those controls for the burner, waiting for those relays to close on the call for heat to activate the burner operation. And it also tees off and goes to the 96 plug, just like the neutral did. And again, branches off at the 96 plug. We're going to go past that little branch. We'll come back to it. but we'll sit down here back at the pump module, and when we power the boiler, basically press that power button, the power hits these two coils in the middle of our pump module. And those two relays will be K1 and K2. So we know that when these get energized, something down here is going to switch or close. So the first one we'll look at is K2. Oh, I'll back that up a bit. K2 here, or K1, sorry. So we've closed the contact here, and now the power sits at all these relay outputs, waiting for those relays to close, and we have power at 156B. So right away, there's power at the 156B. Remember, 156B you can use for some sort of an outlet if you want for power, but it is protected by F1. So 6.3 amp fuse here. If I put a load on this, I have to make sure that I've added up the load on the 21. That's my domestic hot water pump, my 20 output, which is my boiler primary pump, and this 2820, which could be your system secondary heating system pump, your HC1 pump. It could be a domestic hot water recirc pump. It could be an alarm output. It's a programmable output on 2820. But if you add up all of the amp draws of the loads on those, you can't put something that's going to put you over the capacity of 6.3 amps on that fuse. So typically you might use a step-down transformer or something when you're wiring zone valves. That would be acceptable. Some of that on the 156B. It's available there for you to use. And of course, the power is now sitting at all these other relays. So we're just waiting for, for this boiler pump to run. We are going to need the K3 relay up here to energize before the 20 output is going to be powered. K4, same thing. We need the K4 relay up here to energize before the domestic pump will get its power. And the 2820 output is attached to, looks like the K5 relay sitting over here for that to operate. So those are basically stating it, basically in a wait state for those relays to close for them to operate. All right. So let's go back up to the control here and have a little peek at the branches here that we didn't look at previously. So I'm just going to draw them out just to kind of remove some of the neutral wiring and stuff like that to keep the clutter away here a bit. You'll see that neutral comes over and now goes into these plugs sitting over here. That's a little circuit board that you see to the right on the control console. And then I changed the power here to green to kind of give you a little bit of a defining line here of this power as it moves to a different component. And we're sitting now at another couple of relays on the control console here as well. So if we explode that up a bit, that's a circuit board here on the right-hand side that we're looking at, identified in this wiring schematic here with the 53 and the 21 plugs connected to it. That's the neutral outlined in the yellow box there. That little purple cable here is the blue neutral that you see actually in the picture here. And the line voltage, green here, is this little black plug with the white insulated connector plugged into that circuit board. So power comes in, and that's basically, this power is sitting, waiting for these two relays to close. So K11 and the K12 relay are part of the circuit board here, and they need to close for that power to move past the K11 relay contact or K11 or K12 relay contact. And what switches those is a 24-volt DC contact. So that 24-volt DC is actually coming from the control. It's plugged into an X12 plug in the control console. You'll see it right here, little X12 connection, and we plug in the X2. This actually feeds, depending on what the call is going to feed the 24-volt DC to close the K11 relay or the K12 relay. So these relays don't close in parallel. They're different functions, so they will close based on the voltage being present on the relay contacts here. All right, so the switching of the K11 has to be done through the 24-volt DC of the control console, and then it hits a little 2 amp fuse. We go past the 2 amp fuse, and we come out of the 53L connection on the plug here, And that comes down, after it goes through the 53L plug, comes back down to your pump module. So before we get too far ahead, that little connection here, what creates a DC connection to close the K11 relay on this little expansion or circuit board to the right on the control console? And it's basically any call for heat. So effectively, your heating circuits will create a 24-volt DC switching. Your zone control circuit heating demands will create that 24-volt DC demand. Domestic hot water, any external fixed set points that you've created using the DE contact and address 9B in encoding, as well as any 0 to 10 volt inputs in any type of commercial applications or snow melt, whatever you might have attached to the 0 to 10. If they have a demand, that will create a 24-volt power, which will switch one of our relay or K11 relay here to allow that power now to move through that 53L. So now that we've moved through the 53L contact, we're going to be coming down here on X1-2. And once we hit this particular connection, we are energizing the K6 relay. So K6 relay closes, and now we power through a little 4-amp fuse, and we're going down to the L on our multi-plug. And remember, the L in the multi-plug is mentioned in the troubleshooting of that address or value 29 and address 38. So keep that in the back of your mind, the method to my madness here. There's a jumper installed right here in the multi-plug at the factory. So right from the factory, it comes already installed. We move through, and that power just goes directly up to X1-1. So it doesn't go through any other relay or contact. It just powers directly to the X11. And now a little victory lap as you see the little blue line here slowly moving up, and it's going to hit on the 53-1 connection. And once we get power to 53-1, that's when all of the action on the burner side will actually occur. This will create the burner call on or demand on for that burner to start the fan, have the gas valve energized, and all the other components on the burner side here in operation. So if we don't get power to this particular point, then that burner is not going to operate. And that's what we have here. Remembering what that 29 value means is that there's a circuit open between the L and the 1. So that blue wire, or this blue indication of 120 volt, is not making it to this particular portion of the circuit board. So what could cause the power basically to be interrupted at our multi-plug down here? Sometimes you would have some field wiring connected to the multi-plug. And that's the first thing I would examine, is open up the control here, look at that pump module, and have a look at that multi-plug. Is there a jumper in there, or did somebody install something on that multi-plug that could be open at this particular point in time? Specifically, external safeties. So in our manuals, we'll detail things like auxiliary low gas pressure switches. Some jurisdictions, that little automatic reset low gas pressure switch on the gas valve on, say, on the B2HA 399 and 530, because it's automatic reset, they want a manual reset switch on there. They might require you to put that manual reset to low gas pressure switch. You might have an application with a high gas pressure switch that's manual reset. You might have a temperature limit that opens and needs a manual reset on it. Depends on your different areas and different codes that you have to, and bylaws you have to kind of adhere to as a technician. But if that switch opens, we of course separate the power now between the L and the 1, and that 1 is not going to have power on it. So there's a low gas pressure switch. We also have information on wiring things like low water cutoffs. If you need a low water cutoff on your system here, how to do that. And typically in the instructions, the first thing it tells you is remove the jumper on the multi-plug, the 1 and the L, and now you're going to wire your low water cutoff safety contact to the 1 and the L. So as long as everything is in safe operation, the low water cutoff in this instance would act just like the jumper. Power just goes right through. If we get into a position where that low water cutoff is in an unsafe condition and that connection opens, it's like removing the jumper on the multi-plug. basically now the power can't go from L to 1, and the burner is not going to operate. So same thing here, kind of going back to the low gas pressure switch. You see if that's open here, the little blue connection here is open. I'm going to have power here on L, but I'm going to have any power here on 1 because the power is stopping right here. We need to close that gate for that to basically energize that 1 connection. So what are we going to do? We're going to have a measurement here. We have a 29 value on address 38. We're going to take our meter out, and we're going to start basically looking at where is that power being interrupted. So we can have a look first here. This is my meter. I've got one side on the ground on the 40 plug, and the little red lead, and the black lead here is on the L. I would get 120 volt here, but when I measure between the ground to 1, there is 0 voltage here. So that would indicate that that safety has been interrupted, and we need to basically correct that problem and move on. So the safety, it's doing its job. It blocked the burner from operation, and now we need to basically figure out why that safety was interrupted and fix that problem, hit the reset switch, and now our burner will be in operation. If you got the little Viessmann screwdriver, little leap of faith here on this one, you got to ground yourself, and you put your thumb on the top of that little screwdriver, and now you put that down on the power, and you can see here, if I kind of put that back and forth a bit, you can see where that, where that light here very dimly opens on 120. It's actually a 230, 120 or 230 little LED in there, so it lights up a little bit brighter for 230 volt, but certainly does a decent job on the 120 as well. That's just a little carrot for you to come to our seminars when Mark and I open up the doors here in the future. The other areas to check on your 120 volt to ground here is we're just checking out to see where is that power interrupted, where it came up from the control, but it's not coming back down and hitting that little 1 terminal. We can start checking on the left-hand side here. We're basically checking the power at the 96 plug. Do we have power here? Measuring it. That goes over to our relay contacts. So we're checking down here from ground to the voltage on that connection there. The 53L to ground. Do we have power there? And then we'll check over here at the 1 to ground. Is there power there? If there's no power, somewhere in there it's interrupted, would indicate that the board here, our expansion board, is our issue. So if the power is interrupted, our relays here are not sending the power actually through the control, and we've got an issue that we have to rectify. We have to replace this little circuit board. So the part number here, 7509610 is the replacement component. You put that back in, and that would get your boiler back up and operating. The other area to check as well is if power is good on all this, remember that there is a little fuse on the power pump module, which is directly connected to that the K6 relay down at the L terminal on the multi-plug. So if that little fuse pops, for instance, if somebody put a load on that exceeded the limit and we pop that fuse, that would open and you would have all the power up at the top here with the exception of the number 1. But if you check for power down at from ground to the L terminal, there'd be no power there because it was interrupted at that fuse. So the difference there would be if you have power at the 53L at the top here, and you go down and have a look at the contact on the L terminal on the multi-plug. If there's no power there, there's a potential that that fuse could be popped in the pump module, and it would need to be replaced. So you need to replace the pump module if that was the case. And finally, the fault basically address 38 at a value of 33 indicates that the power supply voltage is below your minimum operating level, or there's an internal fuse that has failed. So we check for power or replace the control. So the power we're looking at here, I like to check power right at the control console 40 plug. We just kind of went through the whole wiring schematic. So hopefully you know where that's located at the control console, and measure line to ground here. And effectively, if you're down below about 110 volts, that could start an issue here with your address 38 being a value of 33. So not enough voltage for the control to do what it needs to do, and it's going to basically sit there and wait for that power to get back up to usable level, and the burner would automatically fire. So if you have any sites that have known power issues, it's not a bad idea to put some sort of power filtration on there. But if you have good power, it could be an intermittent problem. So there could be some points in time where you got intermittent issues with low power, and brownouts, etc. over time have an impact on your printed circuit boards, and over time that would have wear the control enough that you'd have to at that point replace the control console. So if the voltage is good there, and you know that that site has good power, then the option here, only option you have, is to replace the control console. And I'm giving you the reasons why there might be some issue. Lightning strikes, power surges also can cause that. So this would be the internal fuse popping in the control console. Water on the controls. So if you get water coming in from things like flue gas recirculation, from the exhaust side of your boiler, dripping on things like gas valves, etc., that are wired directly to your console. If they short out, they can short out the fuses in the control console as well and create that address 38 being a value of 33. So if the power is good, basically if you have a value of 33, the control console would need to be replaced. All right, so that's the address 38 information.
Keep looking for more of these in the future, some more webinars on different topics. The video that Scott was mentioning earlier, there is a 3-part video I'm producing. Part 1 and 2 are already up online on programming this particular control, so you can look on that everywhere from the zone circuits to the heating circuits, and the 3rd part I'm working on is actually looking at some of the diagnostic levels. So again, thanks guys for showing up, and enjoy the rest of your day.